Hi friends, in the last few lectures we have covered the theory exhaustively. We have had 4 lectures for complex variable of JEE standard. Now we will try to solve some problems. These problems have been selected with utmost care. To select these 20 problems we had to search almost thousands of problems on complex variable, so that we can get representative problems which are not repetitive, which have some of these problems are from previous year JEE exams, and these problems have been from our database of more than 1000 problems on complex variables. Now the first problem that we will do is this. Here we have to, here modulus of z1 z minus z2 upon z1 z plus z2 has been given to be equal to k, and we have been asked if for different values of k what would be the graph that this particular equality would represent. So now I just want to revise some theory, and because this kind of pattern keeps on coming in exams in JEE time and again, especially for mains level problem and even in some advanced level problem, this concept is used. Now this complex number can be written as when we divide the z1 from both top and above, this becomes minus z2 upon z1 modulus divided by z plus z2 upon z1 modulus. So let us revise some theory for this kind of pattern. Now this pattern occurs quite often in various exams. Now if modulus of z minus z1 divided by modulus of z minus z2 is equal to 1, it would mean that modulus of z minus z1 is equal to modulus of z minus z2. It would further mean that z moves in such a way that if it is a variable, then it moves in such a way that its distance from point z1 and z2 will remain constant. Now how to find the locus of such a point z? That z is always equidistant from z1 and z2, so it should lie on the perpendicular bisector. So if A and B are 2 points, then CD would be the perpendicular bisector, and it would be representing the this particular relationship. So modulus of z minus z1 is equal to modulus of z minus z2 would always mean that z lies on perpendicular bisector of line joining z1 and z2. There many questions have come in the past in JEE using this particular property. Now here if let us take a couple of examples to understand it even better, that if modulus of z minus I is equal to modulus of z plus I, that is the z1 is equal to 0 1 and z2 is equal to 0 minus 1. So line joining the two is this one, and middle point is origin. So perpendicular bisector is x-axis. So for this would represent x-axis. If we put z is equal to x plus iy in both the sides, and solve it by squaring it, then also we will get the same answer, x is equal to 0. But we don't have that much time in exam, so we have to, whenever we see this kind of relationship, we have to write x is equal to 0. Now let us take another example. If z minus 2 is equal to z minus 4, modulus of z minus 2 is equal to modulus of z minus 4. So this is the first point z1 and this is second point. The middle point is 3. So x is equal to 3 would be the equation representing this line. If we again put z is equal to x plus iy and solve, we will get the solution as x is equal to 2. Now what would be the case if modulus of z minus z1 is divided by modulus of z minus z2 is equal to 0. In that case, what would this relationship mean? Modulus of z minus z1 is equal to 0. That is, z is equal to z1. That would mean z is a point representing z1. So it's a circle. You can also say circle of unit radius with z1 as center. Now the last case, when if z minus modulus of z minus z1 divided by modulus of z minus z2 is equal to k. Let us assume it to be equal to 3 upon 5. Then we have been saying that you will get the same result by putting z is equal to x plus iy. So now let us put z is equal to x plus iy and try to solve it. So what do we get? If we put z is equal to iy and let z1 is x1 plus iy1 and z2 is equal to x2 plus iy2, and then we put these values in this equation and square the same, then we get 9 upon 25 on the right side. So we get 25 x minus x1 whole square plus y minus y1 whole square is equal to 9 bracket x minus x2 whole square plus y minus y2 whole square. Now when we expand this, we will get an expression like this: 16x square plus 16x square plus 16y square, y has been missing here, plus ax plus by plus c is equal to 0. Now in this expression, the coefficients of x square is equal to coefficient of y square. So, and there is no xy term, so this would always represent a circle. I have not written these things, I could always write expanded, but it would be in some form like this: ax plus by plus c is equal to 0. So, the modulus of z minus z1 upon modulus of z minus z2 for any value of k other than 0 and 1 will always represent a circle. Now, which circle? What would be the radius of that circle and center of this circle represented by this relationship? This we have to calculate by putting z is equal to x plus iy in this, and there is no shortcut or no easy method to find out. We just put z is equal to x plus iy, put value of z1 and z2 and solve, and we will get the equation of circle. The only thing we know for sure that this would represent a circle. Now let us come back to our original problem. So if modulus of z1 z minus z2 upon z1 z plus z2 is being given to be equal to k, we on dividing this by z1 z minus z2 upon z1 divided by z plus z2 upon z1. Now minus z1 upon z2 and plus z1 upon plus z2 upon z1 are two different numbers. So it is same as z minus k1, z minus modulus of z minus say z3 divided by modulus of z minus z4 is equal to k. We are not supposed to solve this equation. We are just supposed to tell what would it represent. So in case of k is equal to 1, it would represent a line segment, which is the straight line, which is the perpendicular bisector of the line joining z2 upon z1 and minus z2 upon z1. In case of k, it would be a point represented by z is equal to z2 upon z1. When k is equal to 2, then for all values of k which are not 0 and 1, it would represent a circle. So in case of d, it would be t. And similarly in case of c, because it is not element of 0 and 1, and it is not, it would mean, since this is a half bracket, so it would mean that 0 and 1 are not included. So in this case also, for whatever be the value of k, as long as it is not equal to 0 and 1, it would be equal to this value would always represent a circle. Now let us take another problem. In this problem, modulus of z has been given to be equal to 1 and z has been defined as 1 plus ia divided by 1 minus ia whole to the power 4. Now this concept that modulus of z is equal to 1, that is z is unimodulus, this is quite a frequent occurrence in various problems in JEE. Now how to deal with such problems? So it would look obvious that we can say modulus of z is equal to 1 and proceed thereafter, but how do we proceed? The right way to proceed is that let us first understand what all are possible ways to proceed. First, modulus of z is equal to 1 would mean modulus of z square is equal to 1, implies that z bar is equal to 1, therefore z is equal to 1 upon z bar. So in case if z has been given to be unimodular and we have to prove some equity involving z or 1 upon z, then we can straight away start from the fact that z being unimodular, z is equal to 1 upon z bar. Now another way to deal with such problem is that when z is given to be equal to 1, then z can be taken as e to the power I theta, that is cos theta plus I sin theta. Now it is obvious that if the modulus of z is 1, then z in case of z is equal to r e to the power I theta r would be equal to 1. But in exam, when the question is given involving z to be unimodular, then we may not immediately think. But whenever these kinds of problem come, we have the most important ways to proceed are z is equal to 1 upon z bar, or take z to be equal to e to the power I theta or cos theta plus I sin theta, depending upon the situation. What we should avoid and use only when these two things fail is that modulus of z is equal to 1 to mean that a square plus b square is equal to 1, that is a square plus b square is equal to 1, where z is assuming z to be equal to a plus I and then taking a square plus b square is equal to 1. So we have not used the beauty of the fact that if modulus of z is 1, we have brutally created a few equations which we normally find too difficult to deal with. So in this problem, when we since this is not first, I don't think we can use the first method that z is equal to 1 upon z bar. So let us take z to be equal to e to the power I theta and or equal to cos theta plus I sin theta. Because it is to the power 4, so if we use cos theta plus I sin theta, in that case we can use de Moivre's theorem, or as the French would say, Demoivre's theorem. Now let us see 1 plus I a to the divided by 1 upon minus divided by 1 minus I a to the power 4 is equal to cos theta plus I sin theta. I could have also solved this problem starting from this step, but I went to the background to tell you that why we are starting in a particular fashion. Once we have written this step, 80% of the problem is already solved. But we should not go for the beautiful solution. We have to see in exam within very short span of time, we have to think and find the right path. So unless we have created some rules that okay, in these kinds of problem, if this is giving, then this is the most likely path to start with, and still it is a likely path. There may be a problem, and I have seen a few problems where modulus of z is equal to 1, we have still started with a square plus b square is equal to 1, but more often than not we would be starting with z is equal to e to the power I theta or cos theta plus I sin theta. Now it would mean that if we take the fourth root of this and use the de Moivre's theorem, what do we get? 1 plus Ia upon 1 minus Ia is equal to this cis theta divided to the power 1 by 4. What would that mean? Cos 2k pi plus theta plus I sine 2k pi theta to the power 1 by 4, where k is element of z, and we know as per de Moivre's theorem this would be equal to 2k pi theta divided by 4 for k is equal to 0, 1, 2 and 3. So what would it mean? That 1 plus, if we take 2k pi plus theta divided by alpha 4 to be alpha, then what do we get? 1 plus IA divided by 1 minus IA cos alpha plus I sin alpha. Now this is begging to that we apply componendo and dividendo. So by applying componendo and dividendo, what do we get? The sum of these two terms is equal to 2, and the subtraction is 2IA. So 2 upon 2IA is equal to, if we divide it by 1, then right side would be equal to cos alpha plus I sin alpha plus 1 divided by cos alpha plus I sin alpha minus 1. So solving this, we will get the answer to be 1 upon I cot alpha divided by 2. So this is the value of 1 upon IA. So A is equal to 10 alpha upon 2. Here, so A would become 10 alpha upon 2. We know what is the value of alpha, 2k pi plus theta divided by 4 for k is equal to 0, 1, 2, 3. Now when we put these values, we get the answer as 10, 3 pi by 4 plus theta by 8. That is, these are the 4 values we get, 10 theta by 8, 10 pi by 4 plus theta by 8, and so on. So we know that all roots are real and distinct, and the correct answer is A here. So this is a beautiful problem. We have selected this problem to explain that how to proceed in case modulus of z has been given to be equal to 1. In this problem, the imaginary part of this particular expression, the whole expression, whatever the it evaluates to, is being given to be equal to 0, and we have been asked to find the what the locus of z can be. Now again, the biggest problem for me always in JEE problem has been that where from to start. Now what are the various possible options for us to start these kinds of problems? The options available are that we solve the problem graphically, or we solve the problem by putting using the exponential expression or exponential form of complex variable z is equal to r e to the power I theta, and then which is same as z is equal to r cos theta plus I sin theta. Or what we can do is we can put z is equal to x plus I, old and good x plus iy also does the trick in many problems. And then there is a triangle inequality, that is modulus of z1 plus minus z2 greater than equal to modulus of z1 minus modulus of z2, come close, and it is less than equal to modulus of z1 plus modulus of z2. So these are some of the methods to start, and wherever possible we should use this or these methods in this order only. We should, when we should think along these lines. We should not straight away jump to z is equal to x plus iy and start solving the problem or trying to put re to the power I think. We should, I have given you some of the ways by which we approach the complex variable problems. Now in this this triangle inequality problems can also be solved graphically, but in such cases I would suggest you to do it graphically, because that is more general methods and should be preferred. Once you get a grasp of doing things graphically, I would suggest you should use the graphical method more often. Now let us see what was our problem. Our problem was that the imaginary part of this is being given to be equal to 0. Now although we have to find locus, but we cannot start this problem graphically. We cannot draw what would be the imaginary part of this. So the second option comes to the mind is exponential. If we put z is equal to x plus iy, this would one thing is exponential. It would become clumsy. So if we put z is equal to r e to the power I theta, then also this is something not bad. So we have to, this is a trick problem. Here we have to use z minus 1 upon e to the power theta I. Sorry, this is I, and here also it is e to the power I theta, obviously. So here we have assumed that z minus 1 upon e to the power I theta is equal to u, implies that e to the power I theta upon z minus 1 is equal to 1 upon u. This is a kind of intuitive step, and we have to, with practice, you will get this kind of intuition. So what does this expression become? This expression becomes u plus 1 upon u. Since imaginary part is 0, so what would it mean? That this u plus 1 upon u and its conjugate would be equal. So u plus 1 upon u minus u bar plus 1 upon u bar would be equal to 0. Now what do we get? U minus u bar is common. 1 minus 1 upon u bar is equal to 0. U is not purely real. Then in that case u bar is equal to 1. Then z minus 1 upon e to the power I theta is equal to 1. Modulus of z is equal minus 1 is equal to 1. And solving we get a circle of radius 1. Here keep in mind that u, the imaginary part of u, is not equal to 0. It is u plus 1 upon u's imaginary part is 0. So u may not be purely real. That's why we can say u bar is not equal to 1. So we can proceed further. U minus u bar, u bar would become, in that case u is not equal to u bar. So we can say that u bar is equal to 1, and then we can go and solve the problem. Then it becomes a very easy. So in most of the problems in complex variable or in JEE problems, the first step is the most step. You may not hit the bullseye, but don't go ahead too much if you feel that this is not this your start is not taking you anywhere. So just spend some time thinking initially how to tackle the problem and then proceed. On the question of starting a problem, let us take another beautiful problem. Here modulus of z has been given to be equal to maximum of modulus of z minus 1 or z plus 1. Now where to start? Now we can start thinking, okay, which would be bigger, in which condition this modulus of z minus 1 would be bigger than modulus of z plus 1. So let us just assume that modulus, there would be cases when this would be bigger and there would be cases when this would be bigger. So let us assume that, how do we start? Let us assume that modulus of z minus 1 is bigger or z plus 1 is bigger. Let us assume one of them is bigger. So if that is the case, if modulus of z minus 1 is bigger, then modulus of z becomes modulus of z minus 1. Squaring, obviously in all such problems we start with the modulus of z square is equal to z minus 1 whole square. This, if we represent it graphically, it leads us nowhere, and we have said that modulus of z square is equal to modulus of z minus 1 square, and then we can write in terms of z bar, where z bar is also coming in the answer. So what we can say is modulus of z minus 1 a whole square is equal to z modulus of z square, implies that z bar is equal to z minus 1 bar of z minus 1, which is equal to bar z minus 1. So expanding these, what do we get? Z plus z bar is equal to 1. And if we solve the other equation, if we assume that modulus of z is equal to modulus of z plus 1 and square it, modulus of z square is equal to modulus of z plus 1 whole square, and etc. We again will get modulus of z plus modulus of z bar is equal to minus 1. Now here is an option which says that modulus of z plus z bar is equal to 1. Now whether this one is bigger or that one is bigger, we will get z plus z bar to be equal to either plus or minus 1. So modulus of the whole thing would become 1, whether this one is bigger. Now if we spend in exam too much time thinking which one is bigger, because there is no way we can say that one is going to be bigger or under what condition this would be bigger, we will be going in the wrong direction, whereas a very simple solution can emerge if we start from this way. Now that we have done some heavy funda based problem, let us take a very simple fact based problem in which I will just be narrating a simple fact. If modulus of z plus I minus modulus of z minus I is equal to k, then this would represent a parabola if. Now we know that if it is like this, the modulus of z minus z1 minus modulus of z minus z2 is equal to k would represent a parabola if modulus of k is less than modulus of z1 minus z2. Here z1 is minus I and z2 is I, so the difference would be equal to modulus of I minus minus I, that is 2. So modulus of k should be less than 2, so it would mean that k should lie between minus 2 and 2. So this is a fact you should remember. The question in exam would be like this, that modulus of z plus 5 minus modulus of z plus 3 or is equal to 7. So we have to solve the equation and find the locus of z. So we have to just remember that the first condition we have to check is whether k modulus of k is less than modulus of z1 minus z2. Now let us consider the problem where we will be using the graphical representation. We are given that modulus of z minus 3 plus 2i is less than equal to 4, and we have been asked to find the difference between greatest and least value of modulus of z. Now here, what does this figure represent? This figure represents the circle of center 3 and minus 2 and radius 4. So 3 and minus 2 would be somewhere here. Now this is the, what would be this distance? It is 9 plus 4, 13. So root of 13, it would be less than 4. So if this is the center and circle will be passing somewhere here, and the shape of the circle would be roughly like this. Now what is the modulus of greatest and least value of z? So z represents all the points on or inside the circles as per this particular theorem and the definitions and things we have learned so far. So which point will have the least distance from O, which is inside this circle? Now this is just a geometric situation. Suppose we draw a let us take this particular line. Now this distance is less than this distance, so this is not the smallest distance, and this distance, as is obvious from this figure, is less than this distance, so this is not the biggest distance. So where will we get the biggest distance and shortest distance? We will get that distance when we join origin to the center of this circle and extend it both ways. Then this OQ would become the largest distance from of any point inside this circle and on the circle, and OP would represent the minimum distance. So the trick is to join origin or whatever be the value which we are supposed to find. Suppose we are given z is equal to modulus of z is equal to 7. So then it is 0, this circle with the center 0 origin and radius r. So what would be the value? We have to join the two centers and then move accordingly, and the points where the line joining would be intersecting would be we will get the least and maximum distance only on that line. Now in this case, what is the value of OQ? OQ is nothing but OC plus radius, and this distance is nothing but OC or radius minus OC. And what is OC? It is root of 11. So, and what is the radius? 9 plus 11 is 9 plus 4 is 13. So root of 13. So what would be the answer? We get the answer as 4 minus the radius of this is 4, and this OC is equal to root of 13. So 4 minus root 13 is the lowest distance, and the greatest is 4 plus root 13. So we just by looking at this diagram and making it and this image, we can straight away write the answer, because we know this radius is 4, and all we had to do is calculate this distance, which we can orally calculate as root of 13. Now the minimum distance is 4 minus root 13 and 4 plus root 13, and we get the answer in a jiffy. Now, what is the value of log of a complex number or log of a negative number? See, if log of z is also equal to log of z plus 2n pi I. Just remember this thing. Log of z is equal to of z plus 2n pi I. In this case, log of minus 5 becomes log of minus 5 plus 2n pi I. Now how do we move ahead? We just write this number as exponential form of a complex number, that is 5 into minus 1. Minus 1 we know can be written as cos pi plus I sin pi, that is e to the power I pi. So what does this become? Log 5 plus e to the power I pi, that is log 5 e to the power I. We have to just write it directly. See, just remember that log this 0 can be written as cos 0. This 1 can be written as cos 0 plus I sin 0, that is e to the power I 0. And I can be written as e to the power I pi by 2. Minus 1 can be written as e to the power I pi, and similarly minus I can be written as e to the power 3i pi by 2, or e to the power I 3 pi by 2. So these values we should remember and straight away write. We should not get into this kind of calculation. Just simply write log of minus 5 is equal to 5 e to the power I pi, which is equal to 5 plus I pi, and now we add another 2n pi I to find all possible values of this number. So this is log 5 plus 2n plus 1 pi I. So when we separate it into real and imaginary part, the real part is log 5 and imaginary part of is 2n plus 1 pi. So complex numbers not only help us find the solution in case of quadratic equation where the value of b square minus 4ac is less than 0, but also help us finding logarithm of a negative number. So in this problem, z1 has been given as 6 plus I and z2 has been given as 4 minus 3i. Here it is a typo, it should be z2. See, I am not correcting everything and making it kind of a perfect lecture and using lot of animation to do this and that, because please understand that if we do that, then we can only scratch the syllabus of JEE. JEE is to prepare for JEE needs huge amount of theory, concepts, and examples. So if we just keep on correcting here and there, see, once I have told you that it is Z2, I hope you will take it to be Z2. And in our notes, which are available on Exxamm.com/12439, and you will get the correct part. But right now I don't want to break my flow and do all the correction, stop, go into our database and do all the corrections, because I want to save time and cover as much of as many examples as possible. Now Z1 has been given as 6 plus I, Z2 has been given as this, and Z be a complex number which moves in such a way that argument of Z minus Z1 upon Z2 minus Z is equal to pi by 2. Now here we know that in rotation formula it is Z minus Z1 upon Z minus Z2. Now just to recall, if argument of Z is given as pi by 3, then what is the argument of 5Z? Argument of 5Z is also pi by 3, because if we visualize graphically, 5Z is nothing, the only difference between Z and 5Z is in their modulus and not in the argument. This is obvious, but in exam when some question comes where you have to take I common or 3 or some number common, 3 by 2 is common, and then whether you will be able to ignore that at the spot. So I am just telling you, reminding you that argument of 5Z is equal to argument of Z. And what is argument of minus Z? Argument of minus Z is argument of minus 1 plus argument of Z, which is equal to pi plus argument of Z. So here if we write in, for the sake of applying the formula as we know, if we use minus 1 here, then it is minus this pi plus argument of Z minus Z1 upon Z minus Z2 is equal to pi by 2. So what do we get? Is equal to minus pi by 2. The only impact is that rather than rotating in a anti-clockwise direction, it is rotating in the counterclockwise direction. But now coming back to the main point, that if Z is a point which moves in such a way that argument of Z minus Z1 upon Z minus Z2 is equal to pi by 2, then what does it tell us? See, we have already learned that if this angle, if it is say theta, and theta is less than pi by 2, then we get a major arc. And if theta is equal to if theta is less than pi by 2, we get a major arc. If theta is greater than pi by 2, we get minor arc. So when theta is equal to pi by 2, what does it mean? That Z1 and Z2 would be the diameter, because just assume this is the circle and Z, this is the imaginary circle. We are studying imaginary numbers, so I am drawing an imaginary image. So if this is the circle and this is the angle, and point Z is moving such that this angle is pi by 2, then what does it mean? That this line is the diameter. So Z1 and Z2 represent the diameter, and Z1 is a point on the circle and which is moving in such a way that this argument is equal to pi by 2. So what does it mean? That we have got a circle with Z1 and Z2 and Z on the circumference of the circle. So what would it further mean? That the center of this circle would be equal to Z1 plus Z2 divided by 2. So here we get Z1, Z2 and Z lie on a circle, and Z1 and Z2 are the end points of diagram. The center would be Z1 plus Z2 divided by 2. In that case, what would be the radius? The radius, this would turn out to be equal to 5 minus I, and radius would be Z1 minus Z0 is equal to modulus of I1 plus 2I. So R would be equal to 5, root of 5. So equation of the circle from this is equal to z minus bracket 5 plus I is equal to root 5. So this problem becomes very easy if our concepts are clear. If our concepts are clear, then we can solve this problem in less than 30 seconds. There is no calculation, just application of fundamentals here. Now this is in this case alpha k has been given to be cos k pi upon 7 plus I sin k pi by 7. This is JEE advanced problem, but I am taking it in this lecture because it is explaining a very basic fundamental and it is an easy problem. So if it is cos k pi upon 7 plus I sin k pi by 7, do we know this expression somewhere? We don't know this, but what we know, cos 2k pi upon 14 plus I sin 2k pi by 14 for k is equal to 0 to 13, that we know to be the roots of unity when this alpha to the power 14 is equal to 1 for 14 roots of unity. So, okay, so let us write 2k pi upon 7, 14 and 2k pi upon 14 here. Now, what else we know? That all these roots when positioned on a unit circle, because they are roots of unity, so they would all lie on the unit circle. So what do we know? We know that first one is obviously 1 and then they go on clockwise. Second thing we know that their angles are equal. Third thing we know is that they are all multiples of each other, like 1 alpha, alpha square, alpha cube. All these can be written up to alpha to the power 13. Third thing, and another thing we know is 1 plus alpha square up to alpha to the power 13 is equal to 0. Then what else do we know? We know that these points represents the vertices of a regular polygon of n is equal to 14 because it is the 14th root. Remember when we talked about the cube roots of unity, what were the roots? 1 omega square. So omega and omega square were the conjugate of each other. Then the triangle joining 1 omega and omega square was the equilateral triangle. If we consider 4 roots of unity, what do we get? 1 I minus 1 and I as roots. So here what do we get? We get polygon of side 4. Similarly, in this case, we will get polygon of side with the n sides and all these sides are going to be equal. Now what does alpha k plus 1 minus alpha k represent? It represents the side of this polygon. So alpha k plus 1 minus alpha k is, suppose the side of polygon is L and we are summing it over 12L. So what do we get? 12L. And alpha 4k minus 1 or alpha 4k minus 2, these are two consecutive for 1, 2, 3. These are also 3 consecutive roots of unity, 14th roots of unity. So the difference between these two would be, if we put L k is equal to 1, what do we get? 4 minus 1, 3 and 4 minus 2, 2. So alpha 3 minus alpha 2 and so on. So these are also, so each of them would also be equal to L. So it is 12L divided by 3L. So answer is equal to 4. So without touching pen, just by concept and understanding of the units, roots of unity, we have solved a JEE advanced problem, and in the process we have cleared our concept also very easily. So we get the correct answer as 4. This was the in this question, this was a question of JEE advanced. I don't know which year, but here the solution was supposed to be between number 1 to 9, so that it was that type of question. So answer here is 4. Now in this problem, 4ac is given to be greater than b square. Here for a quadratic equation, ax square plus bx plus c is equal to 0. and A plus C has been given to be equal to A plus C has been given to be greater than B. Then we are supposed to find which of them are correct. And see, 4AC minus B square greater than 0 means roots are imaginary. It means the quadratic equation with ABC being real would be a parabola not touching the x-axis anywhere. So now whether it is upward facing parabola or downward facing parabola below the x-axis or above the axis, so this we have to find from this particular condition. Since A plus C A minus B plus C is greater than 0 and ax square plus bx plus c has been given to be equal to the value of fx, then what do we have? F minus 1 is equal to A minus B plus C is greater than 0. This is a bit of intuitive step, but not much. So A plus C is greater than B. So what do we get? A plus C. Since A plus C, what do we know? F minus 1 is greater than 0. So this would be function such that if for one value, if we are able to say that if ax square plus bx plus c is greater than 0, then for all values, for all real values, f of that value would be greater than 0, because it is not cutting or touching the x-axis anywhere, so it is lying all above. So for all values it would be positive. If f of minus 1 was less than 0, then for all values fx would be negative. So now it is just a question of putting different values and we will get the solution. If we put f1, then f1 is also greater than 0, so we get this. Similarly, we get a is equal to greater than 0 and all that. So that is not the issue. So correct, but this is more than one correct answer, so all the options would be correct. Here it has been written only A, but A, B, C, D all would be correct. So with these dozen odd problems, we have learned around 12 tricks which are quite exhaustive in nature, and the notes, the questions, the theory portions which we have taught during these questions are available at exxamm.com/12439. In the next lecture, we would do some problems for JEE Advanced. Those problems are also basically conceptual and involve lot of tricks. So even though you are not targeting JEE Advanced, I suggest you go through that lecture, because if you want to score really good marks in JEE Mains, you have to raise your level to JEE Advanced. Okay, thank you.